Dear students, welcome to Basic Electrical Engineering course. The course code is U18E205. Myself, Professor C. Venkatesh, Department of EEE, and I'll be handling the subject for you, Basic Electrical Engineering. With the introduction video, I hope we have seen about the course. Today we will discuss the simple and fundamental requirement to understand about the concept of electrical engineering. In the today's class, we'll try to represent the network elements and define basic definitions of current, voltage, and power. Electrical current is actually the flow of free electrons in a conducting material. You know that if a body is to be moved, a force has to be exerted on the body. So similarly, if the charges are to be moving in the conductor, it requires some external force. So what is that force and what are these charges that we will see today? So the free charges that are present are the electrons which can move freely. Now if for example we have a conducting material, for example copper strip, and this copper wire or strip is connected to a battery of suitable voltage. This external voltage connected to the conducting material acts as a force and drives the charges through it. So the flow of electrons through the conductor is called as the current. You can see here electrons are coming out from the battery. They flow through this connecting wire through the conducting material and then come out of the conducting material, pass through the wire and then enter the positive terminal of the battery. Electrons are the charges which are responsible for the flow of current, but as they are negatively charged, we consider positive charges as the reference charges, and with that, if electrons flows from negative terminal to positive terminal, current is the flow of positive charges, and hence the conventional direction of current will be opposite to that of the flow of electrons. The unit for the current is amperes, and the current is defined as the amount of charge flowing through the conducting surface per second. So flow of charge per second, Q by T. So Q represents the total charges, and per unit time, how much of charges that are flown, that gives the current. So I is equal to Q by T, and that is equal to N into E by T. What is the total charge? Number of electrons into electronic charge. You know that electronic charge is given by minus 1.6 into 10 to the power of minus 19 coulomb. So if, for example, if Q is equal to 1 coulomb and T is equal to 1 second, then current will become 1 and the unit for current is amperes. So one charge is nothing but this much amount of electrons are to flow. If 1 coulomb of charges are to flow, then how many electrons are required? 6.24 into 10 to the power of 18 electrons are to be flowing through the conductor. So 1 ampere of current is set to flow through a wire if at any cross section 1 coulomb of charge flows in 1 second. So for this flow of charge, we have seen that external battery was connected to the copper strip, and this acts as the external potential or the force. This acts as the external potential of the force. So when a body is charged, work is done in charging it. So if I say that the body is charged, there is some work is done that is to charge that battery. So the capacity of charged body to do work is called as the electric potential. If the body is charged more, if the conducting material or the battery is charged more, then it has a great potential. So therefore, electric potential is represented by V and is defined as work done per unit charge. Work done per unit charge. That is W divided by Q. So this unit for electric potential is joules per coulomb. Joules is this work done is in joules and Q is in coulombs. So joules per coulombs, or it is also called as volt, VOLT, volt. So if 1 joule of work is done per 1 coulomb, then the electric potential available is 1 volt. Potential difference. If normally if there are two conductors, each conductor will have their own potential. Let us say we have conductors or bodies, two bodies A and B. One is charged at uh, one is charged at 5 volts and another is charged at 3 volts. Then there exists a potential difference between these two. A has potential 5 volts, B has potential 3 volts. The potential difference between them is 5 minus 3, that is 2 volts. And we can say that A is at higher potential than the body B. And what happens if I connect a copper wire between them? If a copper wire is connected between them, then the current flows from higher potential to lower potential. The current direction will be like this. Okay, current flows from higher potential to lower potential. It means in reality what happens? Electrons flow from B to A. Electrons flow from B to A. So electric power, the rate at which work is done in an electric circuit is called the electric power. So electric power is defined as work done in electric circuit divided by time. So we know that the potential is work done per unit charge. Okay. So how do we get this? We'll see. Then work done will be equal to what? V into Q. And Q is nothing but what? Current into time. So therefore, work done per unit time, will be equal to V into I. So that is defined as the power. So work is VI into T. So it is, we call this work done in electrical circuit, we call it as energy. So energy is V into I into T, and the power is work done divided by time. So therefore, it comes to V into I. Or we will go through what is called as Ohm's law. In that, this current can be written as V divided by R. So therefore, power becomes V into I, and that is nothing but V square by R, or that is equal to I square into R. So later in Ohm's law, we will see that voltage across a conducting material or a resistor is V is equal to I into R. Okay. And the units for this power is joules per second, work done per unit time. So joules per second, or it is also called as watts. So dear students, today we have just seen the simple concepts in continuation of the introduction of the course. That what is the concept of current, voltage, how voltage difference or potential difference is created, and how this helps to perform the electrical work. Yeah. So what is the maximum safe current flow in a 47 ohms 2 watts resistor? Let us say we have 47 ohms resistor which is rated to 2 watts. What is its current capacity? So we'll learn after Ohm's law, you can solve this one. But you can now see that work done or the power, okay, I'll write that P, work P is equal to I square into R. I square. Okay. So now we know P, we know R, and then you can find current. So it comes to 0.21 amperes. What is the maximum voltage that can be applied across a 100 ohm 10 watts resistor in order to keep within the resistor's power rating? So if I have a resistor of this one which is rated to 10 watts, what is the maximum voltage that can be applied to it? Because if I apply more voltage, more current will flow and resistor gets damaged. And hence there is a limit of voltage to be applied. What is that voltage? So again we have the formula P is equal to V square divided by R. P is equal to V square divided by R. So you know P, you know R, and hence you can find voltage, and that comes to 31.6 volts. Please try to solve this one and verify. A current of 4.8 amperes is flowing in a conductor. The number of electrons flowing per second through the cross section of the conductor will be, if this much amperes is flowing, then how many electrons are flowing? We know that 1 ampere is nothing but how many uh, electrons. So with that we can calculate, and hence that comes to 3 into 10 to the power of 19 electrons. So having completed discussion, dear students, you should now be able to represent the network elements, and particularly we have seen what is current, what is voltage, electrical energy, electrical power. So refer chapter 1, topic 1.1. Your prescribed textbook is K. Umarov, author. The book title is Basic Electrical Engineering. Thank you, students.